Okay then, welcome everyone. This is advanced lecture 11 and we are dealing with many effects of current. Today we will try to concentrate mainly on the problems. I think we have done the theory part. I have told you what you were supposed to know, and I hope did you I asked you to practice. Did I ask you to practice questions or did I ask you to do something else? Have you practiced any questions here in this part? No.
Yes, sir. Questions.
Yeah, you have done questions. So were you able to do them? Anyways, let's not waste any time and let us begin with the first question for today. A question of this nature came in JEE Advanced some 3-4 years back, probably. Don't remember the exact year. It came in JEE Advanced, and the question was very simple: find the magnitude of magnetic moment of the current carrying loop. Each side of the loop is 10 centimeter. You can write it as A, and the current in the loop is I. Whatever values don't matter. What matters is that you understand the logic behind it. Okay, how will you get the how will you, I mean, if they ask you, they might not ask you the magnitude, they might ask you the magnetic moment ka vector. So if you can tell me the answer in vector, that would be better. So what's the answer for this one time?
Yes, sir.
I'll give you 2 minutes. So I think you have done this and it is pretty simple. These are two square loops. Yes or no?
Yes, sir.
Magnetic moment is I into A. You can find out the vector. You turn your fingers in the direction of current and the direction of thumb will give you the direction of area vector. That would also be the direction of the magnetic moment vector. And area is A square. Current is I. So I into A square. For one loop, it will be going downwards. For the other loop, it will be going into the board. Yes or no?
Yes, sir.
So that will be I a square minus j and I a square minus k. If I take x axis, y axis, and z axis like this. Yes or no?
Yes, sir.
So basically, your answer in magnitude would be root 2 into m, where m is the magnetic moment of one loop, and the magnetic moment of one loop is I into a square. I hope you got this.
Yes, sir.
Yes or no?
Yes, sir.
Okay, that takes me to this question. And these are the type of question that you can expect in a JEE. A circular coil of 25 turns and radius 6 meters. You can take turns if you want to simplify the answer as n, radius as r, and carrying a current of 10 amperes, you can take it as I. Is suspended vertically in a uniform magnetic field of magnitude. You can take it as B. The field lines run horizontally to the plane of the coil. Calculate the force and the torque on the coil due to the magnetic field. In which direction should a balancing torque be applied to prevent the coil from turning? Do we understand this question?
Yes, sir.
The question is pretty simple. I think you might have seen this question anyway because this is a very general question. But these are the type of questions that are going to come. So I've given you N, R, I, B, and I'm waiting for your answers. I'll wait for 2 minutes. It's a simple question. Just concentrate. Okay, let's go about and solving this. As I told you, I was not interested in the numerical values. I was more interested in getting the answer in terms of algebraic quantities. The force on this loop is zero. Yes or no? It's a closed loop placed in a uniform magnetic field. The force is zero. We understand this. Yes or
sir.
no, beta?
Yes, sir.
Now to find out torque, what we got to do is just remember that torque vectorly is m vector
M by
cross
M.
b vector. Now, if I just want to find out the magnitude, it would be m into b into sine theta. Yes or no, bacha?
Yes, sir.
And here, what is the angle between m vector and b vector? Remember, this
Sir.
b vector is horizontal, and if you look at the direction of current, the m vector would be going into the plane of the board. Yes or no?
Yes, sir.
So the angle is simply 90 degrees. The value of m is I into a square. B is given. theta is 90, and you have your answer straight away. So answer is Ni pi r square into b. That was the answer I was looking for. Do you understand this? The values
Yes,
are
sir.
irrelevant. The values are irrelevant. If the question comes in a JEE, they are not concerned about the calculation part that much probably. Do you understand?
Yes,
Do you
sir.
understand this, bacha?
Yes, sir.
You got this? Remember, whenever a question comes without a diagram, it might look a difficult question, but it might be very easy. In any ways, any question that comes in a JEE is an easy one. It is just checking whether you know the fundamental things or not. Here, the only thing you got to know is MB sine theta. Yes or no?
Yes, sir.
So remember this, any question that comes is a simple one. And here I have a question where six positions are given and they're asking you a uniform magnetic field of 5,000 Gauss. So it is in a CGS unit anyways. It is immaterial. I can just call it B. Is established along positive Z axis. So you can see magnetic field is along positive Z axis. Rectangular loop of side whatever A and B carries a current of I suspended in this magnetic field. What is the torque on the loop in the different cases as shown in the figure? What is the force in each case? We know the answer for this one, right? What is the force in each case? What is the force in each case? Hare? What is the force? Okay, your mic has gone. Force is zero. We know this, yes? Remember, whenever a question comes, wherever you have a closed loop, any size, any shape, any dimension, placed in a uniform magnetic field, the answer of force is always zero. So force is always zero. We have to find the torque in all the cases. Magnetic field is B, current is I, area of the loop is A. You can give your answers in terms of that. Which of the following corresponds to stable equilibrium? That is what you have to also tell me. There are six cases given A, B, C, D, E, F, and this will encompass everything that could be asked in a question that comes in a JEE. So I'll give you 2 minutes, and I hope you can get the mic working. Doesn't matter if the mic doesn't work, you can just signal and we will get there. Give you 2 minutes to solve this one. So, how do you go about this? What will be the torque in this case? What is the angle here? The angle here is 90 degrees, yes or no? So torque is NIAB. The angle here is also 90 degrees. So torque is NIAB. The angle in this case is also 90 degrees. So torque is NIAB. Yes or no? Right? The torque in this, the angle in this case is 0 degree. Yes or no? So this is the condition of stable equilibrium. I have janbuzke left case number D. Yes or no? And the case here is 180 degrees. This is unstable equilibrium. The only case which might require a bit of thing is this case. What is the angle in this case? What is the torque in this case, which is case number D? Remember, how is the loop turned? How is the loop there? Remember, if you look at the diagram, it is turned. If this is the ZY plane, ZY plane, it is turned like this. It is turned like this. It is turned like this with an angle of 30 degrees. Now, if this loop was in the ZY plane, then the area vector which have come out in the x-axis, positive x-axis. But if I turn it like this, angle of 30 degrees, so what will happen? If this is the original angle, if this is the original area vector coming plus x, it will turn like this. Yes or no? will turn like this. It will turn like this, and you just find out the angle between area vector or magnetic moment and magnetic field. That is the only thing that you will have to understand. You got this? Yes or no? So I hope you got the answers to everyone, to all the cases. Great. This is just a confirmation of the answers here. You can check it. Confirmations of the answers here. Case number A 90, B 90, C 90, E0, F180, TOG is 0, and this is case number D. I hope you were able to do this. Yes or no, beta? So then we can move on to the next set of questions. And I think we were doing which questions? Let me just get you there. So I selected the question, and I think the question is here. Yes, this is the one that I selected. Okay, here comes the first question now. Remember, we are talking about force on a current carrying wire as well as force on a moving charge. Figure shows. What does the figure show? Two long metal rails placed horizontally and parallel to each other at a separation of L. Now, these type of questions, they are very common in the chapter of EMI, but here this question is in magnetic effects of current. A uniform magnetic field exists in the vertically downward direction, as you can see. A wire of mass M can slide on the rails. The rails are connected to a constant current source. So basically, this will give a constant current to the system. Do we understand this? A constant current source. I mean, this thing has gone up and down. A constant current source. So this gives a constant current. In the circuit, the frictional coefficient between the rails and the wire is mu. So somewhat mechanics is there. What is the maximum? What should it should be should? What should be the maximum? The minimum value of mu which can prevent the wire from sliding on the rails. This question will come again in a chapter of EMI probably, where probably they will give it a initial velocity and they will ask you what will happen to that. Anyways, right now we are not in EMI. Right now we are in magnetic effects of current. So I'm giving it a constant current. What should be the minimum value of V which can prevent the sliding of this wire on the rails? Describe the motion of the wire if the value of mu is half as found in the previous part. These type of question, they will always come in a comprehension or a multiple choice thing where you might have to solve for more than one unknown. Have you understood the question? Understood the question, beta? Have you solved this question before? Let me give you 2 minutes and I'll wait for your call. So how are you supposed to solve this? You just have to find out how much force is acting on this wire, yes or no? And that much force must be provided by the frictional force. In that case, the friction would be static friction, yes or no? We understand this? If it does not move, it stays in equilibrium. That has to be static friction. You just find out the force on the wire. Force on the wire is ILB, as very evident. That must be equal to mu s, static friction, mg. So mu s will be equal to ILB by mg. Yes or no? It was pretty straightforward. Now, what happens if the frictional force or the coefficient of friction is half of that value? Then obviously this wire will start to accelerate. Yes or no? One half of the force will be gone against friction. The other half of force will remain ILB. That will have a constant acceleration ILB by 2m. And it's a straightforward answer. Yes or no? So it was straightforward question. Now it's a very simple question. Just to check whether you remember what I told you in the last class. This is a semicircular loop of wire. It could be a wire which is of irregular shape. It is kept in a constant magnetic field. B, remember B is along the horizontal. What is the force on this wire? It could be a semicircular wire. It could be wire of any other shape. I hope you understand the thing that I told you. What is the force on this wire? How will you find out the force on such a wire? The force would be zero because what you got to do is just complete the wire and then find the force on the entire loop, which is zero. The force on this part is equal to the opposite the force on the other part. But here the other part is parallel to the magnetic field. Force on that other part is zero. Therefore, force on the entire thing is zero. I just wanted to check it, and that was the only reason this question was given. Let us not get much into that. Again, there is a different variation of the same question. Since it is there, let me show you. And while I move further ahead, what is the resultant magnetic force and torque about C and P? Remember, there are 2 points given. C is the center of the loop, and P is a point on the loop. So that is different in this question. You obviously know the answer for the force. Yes or no, bacha? Force is zero? No, force is not zero. So you have to complete the wire first, and it will be 2IRB. Yes or no? Talk about C is talk about C is pretty simple, and IAB. Yes or no? The sine theta. That is very simple. What about the talk about the point P? And that is what you have to tell me. I'll give you 2 minutes. Remember, these questions are the one that if you can do it correctly now, you would get a lot of confidence. I'll give you 2 minutes to do that. Remember, there are two questions here. Talk about point C and talk about point B. Remember, this is not a closed loop. Remember, this is not a closed loop. Remember, this is not a closed loop. You can find the force on the wire by closing the loop, but you cannot find the torque on the wire using closing the loop because that is wrong. I hope you understand the question, beta. Best of luck. 2 minutes. Okay, then how are you going to do it? To find out the force was simple because we just completed the loop and we got the answer. Now let us look at what is the torque on this loop about the center C. I guess you would have got this answer at least. The torque on the loop about the center C would be zero. Yes or no? Because all the forces are radially outward and they are passing through the center. So force on the torque of forces about center is zero. So torque about C is zero. That is the first thing that we must understand. Now let us talk about the torque about this point P. So what we have done, we have moved an angle theta and we have taken a small element. The small element experiences a force dF. And we found the torque of this force, which is obviously passing through the center about this point P, and this is simply equal to this force dF multiplied by this distance. Let me call it as PO. Yes or no? This force is I into length, which is RD theta, into magnetic field, into angle between the current carrying element DL and B, which is 90 degree. Do we understand this? This is the small force DF. This is R, this is perpendicular, so this distance becomes R sine theta, So you multiply it by r sine theta and you integrate this equation, theta varying from 0 to pi, and here is your answer. It is simply integral of sine theta from 0 to pi. That would be equal to 2, and your answer comes as 2I BR square. Do you understand this? Will you remember this question, how it is done? You remember this? I don't think you would have to even do it in the examination hall. You would be able to take the answer as soon as you get it. Now this is a question, and I will just show you a diagram of this question, because you have an infinite wire carrying a current I. At a distance A, you have a square loop of edge length A. You can make it different as well. You can make this length, this distance as B, and this length as A. What is the force acting on this loop? Remember now, bacha, this loop is not placed in a uniform magnetic field, because magnetic field created by a infinite wire. In fact, remember, whenever an infinite current carrying wire is given to you, there is only one reason why that wire is given to you, and the reason is that it can create a non-uniform magnetic field. So you have an infinite wire carrying creating a non-uniform magnetic field. You have a square loop placed in that magnetic field. Such questions will come a lot in magnetic flux. Next question will be to find out the magnetic flux. Then it will come in EMI and all those things. What is the force on this loop of wire? I'll give you a minute to do it. So as you can see, this is a straightforward question. Even though it looks like a question of non-uniform magnetic field, non-uniform magnetic field is only applicable for this wire and this wire, but you understand that whatever force acts on the lower wire and whatever force acts on the upper wire, they will cancel out each other, yes or no? And that force will come in the form of ln A plus d by d. I hope you have done that, right? So that force is going to cancel out. The only force is between that acts on this wire vertical and this wire vertical. Remember, when two wires are carrying current in the same direction, do they attract or do they repel? When two wires carry current in the same direction, do they attract or do they repel? When two wires carry current in the same direction, remember this. And this is how definition of 1 ampere is forced between two parallel wires carrying current in the same direction. They will always attract each other, yes or no? If they carry current in the opposite direction, they will repel each other. Will you remember this? You can easily find it out using magnetic field and magnetic force as well. Magnetic field created by this wire will be going inside. Now if you do DL cross B, first wire, the vertical wire will be attracted and the second wire would be repelled. So attracted, therefore minus I, and repelled, therefore plus I. Attraction force is more than the repulsive force because the wire which is carrying current in the same direction is closer. So this entire loop will be attracted, yes or no? Then to find out the force is pretty simple because both the wires are placed in uniform magnetic field. Magnetic field does not vary along the vertical line, it only varies along the horizontal line, and the answer is pretty straightforward after that. You could have been asked, as I told you, there's a current carrying wire like this, and then you have a horizontal wire like this. Then you will have to apply the technique of integration. I hope you know this. I've already told you the answer. You go a distance x, then you go a distance dx, you find out the force on this small element and you integrate it. You remember this? Okay, that brings us to the next question, and the next question is the question where again things get mixed up, and whenever things get mixed up and there is SHM coming into the picture, the question becomes a bit more attractive, and this is how the question looks like on the next one. In the figure shown, AB and PQ are wires carrying current I1 and I2. AB is a wire which is infinite. PQ obviously is a small wire of length L, mass M, uniformly distributed. They are both horizontal, kept in the vertical plane, so weight is acting downwards. The PQ is in equilibrium at a height h. Find height h in terms of the given quantities. If PQ is displaced vertically by a small distance, prove that it performs HSM. Find the time period in terms of H and G. I don't think you would have seen this question before, but it's a simple one. It will also check whether you understand the simple SHM wala things. I'll give you 2 minutes to do this. The time starts now. So, how do you go about doing this? The first part is pretty simple. You can easily find the value of H. You can easily find the value of H because the weight which is trying to pull it downwards must be balanced by the magnetic force between the two wires. Mu naught I1 I2 divided by 2 pi h into L shall be equal to mg. From here you will get the value of h. You got it, yes or no? Then what you do is you displace it slightly. If you displace it towards the wire, repulsive force will become more. Yet the repulsive force, because the wire is now brought closer, will become more than the weight, so it will try to push it upwards. This is the resultant force. Now you can put the value of h and you will get it like this. You just put some approximations and you will get the time period like this. Yes or no? It is pretty straightforward after this. Yes or no? So remember these questions, and if these questions come, well, you are quite lucky then. You can simply just mark them and move further ahead. This is one of my favorite questions, which I did in the time when I was of your age. This is from a book. Everyone knows it. Erodo. It's a question from Erodo. A loop with current I is in the field of a uniform straight wire. It is missing from here. This is the wire carrying current I naught. The plane of the loop is perpendicular to the straight wire. Find the torque acting on the loop. This is given as A. This radius is given as B. This loop carries a current I. The straight wire carries a current I naught, and 2 alpha is the angle subtended by this loop at the wire. I'll give you 2 minutes to solve this. Have you seen this question before? Okay, do it. So how this question has to be done? Now the way it is solved here is okay. You can do it this way. You just have to check your answer. Did you get the same answer? Did you get the same answer? This one? Mu naught I naught into B minus A into sine alpha by pi. Do not get this answer? Okay. How have you done this? Now, how this is solved here in this sheet is not the way that I would have solved this. But this is also good. What they have done is they've taken a small element, they found out the magnetic moment of that element, taken the torque on that, and then they have double differentiated it. They've used two integrals, which I'm not a very big fan of. But if I would have done it, how would I would have done it? So I'll tell you my way. My way is pretty simple, and how I would have done this would be like this. I'll try to do it here only so that I don't miss anything. See, this is a current carrying wire carrying a current I naught like this, right? I would take, now remember, on this part there is no force acting on this part, and this part, because magnetic field because of this current carrying wire and these two circular arcs, they are in the same direction or opposite direction, so there is no force acting on these two parts. Yes or no? Do we realize this? Okay. Now, if I assume that this wire carries current into the plane, oh, let me take it outside the plane. It would be easier for me to move my hands. If I assume that the current is outside the plane, and if I find out the direction of magnetic field, what do? Is I move a distance x from this loop, x from this current carrying wire, and take a small element of length dx over here. Similarly, I will take an opposite element here of length dx. Are you getting my point, beta? Then the magnetic field will be going perpendicular like this here. Whatever force acts on this part, the opposite force in the opposite direction will act on the other part. Basically, these two forces will make something known as a couple. Do you remember what is a couple? So this force df here, this is db. Now if I find out the magnetic force on this, dl cross b, dl cross b, the force will be pointing outwards. So force on this element will be pointing outwards, df. Similarly, force on this element would be pointing downwards, and this df will be equal to I, the current in this wire, into dx into magnetic field. Magnetic field B will be mu naught I by 2 pi x. So it varies. Are you getting my point, beta? And it will be multiplied by the perpendicular distance between the two forces. Remember, what is the force created, what is the torque created by a couple about any point in the universe? I hope you know this. If this is a force F and this is another force F, how much torque this couple will create is simply one of the forces multiplied by this angle alpha. Do we know this? By this length L, yes or no? Now here there are two forces, one coming out, one going in. You just have to find out this distance, this perpendicular distance, and it will come in terms of x and theta. I think it will come as x sine theta or 2x sine theta. Yes or no? And you just integrate this x from a to b, you will get b minus a. X will get cancelled because there is an x in the numerator and x in the denominator. 1 alpha will come, 1 2 will come because it is multiplied by 2. That 2 and this 2 will get cancelled, and you will get this answer. Are you getting my point, bacha, how I've done this? Have you understood what I'm telling you, beta? I have not solved this, but I hope you have understood this, right? So this was a question taken out from my favorite book. Actually, in the time that I was seeing this question, I was looking for a different question on this talk on a loop, but I could not just locate it. So I'm sorry I could not locate it. But anyways, let us move forward ahead. Let us move ahead and let us move on to questions of this nature. I want to cover every question that is possible so that if a question comes, you would be glad that you have done a question of similar nature in the class, and this is the next one that comes on you, and I hope that you can do justice to this. A current I is equal to 2.5. Forget 2.5. Current is I. Flows along a circle x square plus y square is equal to r square. X and y is centimeter. What is the magnetic field at point 004? It's a simple question. I'll give you 2 minutes. Well, this is a straightforward question. Remember, don't get bamboozled by the language of the question, because the language of the question might be getting you into a trap. The question is as simple as this. You have a circular current carrying wire having a radius of 3 centimeters or 3 meters, whatever. And then you are supposed to find out magnetic field on the axis of the loop. at a distance of 4 centimeter or 4 meter from this, you just have to apply the formula of magnetic field on the axis of a circular loop. Do we understand this beta? This is how questions are framed, and a simple question may look a very complicated one. It is as simple as it gets. The loop is in the xy plane. X square plus y square is equal to 3 square or r square, and they are just asking the magnetic field on the axis of the loop. Remember, there could be a question which could be of similar nature, but the loop is very small, and then they ask you to find out the general magnetic field at any point. Remember, in that case, you have to convert this loop into the magnetic moment of the loop, and then you can apply the formula for magnetic field on the axis of the bar magnet or on the perpendicular bisector. Do we understand this? So there could be a question like this where the loop is very, very small and the distance is very large. Remember, then it's a question not on loop, it's a question on magnetic field due to a bar magnet. Will you remember this? These are the things that you must remember. And here comes a question again. Looking at the question, it's a single option correct type question, which is not my favorite because they are very simple. Anyways, remember the most difficult questions are multiple choice, and this is a single option correct. There are constant electric field E naught J, remember, and magnetic field B present between two plates. We have done this question before, right? We had left a particle here. Remember the path of the particle I told you in the last class? Yes or no? Cyclotron. Right? Cyclotron? Cycloid. Remember that cycloid. Remember the equation of the cycloid. Okay, it's present between the plates P and P dash. A particle of mass m is projected. It's projected along y-axis with a velocity v1. After moving on the curved part, what is the equation of this curved part? It's a cycloid. Remember, it's a cycloid. Remember, on this curved part, it passes through point A, just grazing the plate P with velocity v2 again. So this velocity is becoming perpendicular to the original electric field. Do you understand the same question put in a different way? The magnitude of impulse, remember I told you they will never ask you the equation of paths. They will frame questions on that. The magnitude of impulse, remember the magnitude of impulse F delta T is delta P vector provided by the magnetic force during the motion of the particle from origin to point A. Question is pretty damn simple, and your options are there A, B, C, D, and I give you 2 minutes to think about this. Remember, this is how questions are framed in a JEE. So what is the answer to this one? Remember, and I told you that many a times. Impulse is the change in momentum. Yes or no? Now, what is the change in momentum? The final momentum is mv2 along the x-axis. So mv2i, the initial momentum is mv1 into j hat. So if I talk about the total momentum, total change in momentum, which I call it as impulse or j, that total change in momentum is mv2i minus mv1j. Yes or no? This is the total change in momentum, but they are not asking the total change in momentum or the magnitude of total impulse. They're asking only about what is the impulse provided by the magnetic field. Now, how do you find the impulse provided by the magnetic field? Remember, magnetic field does not change the speed. It only changes the direction of velocity. Now again, that will become confusing because you say, sir, if it is only changing the direction of velocity, how will I find out the change in direction? You can see the change in direction is 90 degrees, but how will I write the impulse in terms of 90 degrees? Well, then there is a small thing that you have to remember. This electric field is constant. It is always along the y-axis. So it can only change momentum along y-axis. The magnetic field actually is changing momentum in the xy plane. Magnetic field can only change momentum along the y-axis. So whatever momentum has changed along the x-axis, that is due to the magnetic field. There is no momentum in the first case when the particle was projected. There was no momentum there along x-axis. Whatever momentum has come along the x-axis, it has only come because of the magnetic field trying to turn it cycloidal path, and therefore the answer is m into v2. Do we understand this? So this is how you apply whatever you have learned. Remember, they will not ask you what is the equation of motion or something like that. They will always ask you questions in different ways. Comes the next one. Are you ready for the next one? Here's the next one, which is pretty simple. All questions are simple. Three identical charged particles A and B are projected perpendicular to a uniform magnetic field with velocity v1, v2, and v3. Uniform circular motion. v2 is the highest. Time period such that t1, t2, or t3 are their respective time periods, and r1, r2, r3 are their radii of circular path. Which option is correct? A, B, C, D. 1, 2, 3, 4. Remember, you will always get questions of this type based on ratios. 2 minutes. Again, this is a pretty straightforward question, beta. Just have to remember simple things. Time period is 2 pi m by qb. You know this one? Yes or no? Radius is mv by qb. Can find the ratio from there. R by t. R by t is directly proportional to v. So whose v is higher? The ratio of R by t. We should not call it ratio. R by t is basically distance divided by time. Simple. Yes or no? Did you get it? See, the questions are pretty simple, but they might look complicated because of the language in which they are put. Don't get bamboozled by those languages. That is why we are solving all types of questions that are possible. And here is the one which I think you should be able to get quicker. A wire carrying current of 4 amperes is bent in the form of a parabola. X square plus y is equal to 16 as shown in the figure, where x and y are meter. The wire is placed in a uniform magnetic field B, 5 teslas, 5k teslas. The force acting on the wire is, this is pretty straightforward. I'll wait for a minute for you to do it. So again, this is a simple straightforward question. Wherever you have any loop placed in a uniform magnetic field, the force should be 0. This is not a complete loop. So what I'm going to do is I'm going to complete it with a straight line like this. Now the force on this loop is 0. So whatever force is acting on this wire, the opposite force is acting on this wire, on the parabolic wire. You have to just find out its length. You put the value of y, you will get the value of xs plus or minus 4. Yes or no? So the length of this wire is 8. This wire is like this. Magnetic field is going outward. So force on this blue wire is acting in the upward direction. Therefore, force on the loop should be acting in the downward direction. I into L into B. I hope you got this correctly. Yes or no? Congratulations then. Then comes this one. And I hope that you can do wonders with this one as well. Remember, the question might look a bit complicated, but it is quite simple. A disk of radius r carrying charge q, wow, is rotating with a constant angular speed omega in a uniform magnetic field B about a fixed axis as shown in the figure, such that the angle made by the axis of the disk with the magnetic field is theta. What is the torque applied on the disk? Simple question. Do not get confused with the language of this. I'll give you a minute, 2 minutes. Well, again, you must remember what I told you. The problems are simple. The only thing is you just have to think and have confidence that you know how to do it. Remember, I told you about this formula. M by L is Q by 2M. From here, you can find out the magnetic moment of this disk, which is rotating with a constant angular velocity omega. How do I find the magnetic moment? You just multiply I with omega with Q by 2M. You get the magnetic moment. You just cross it with B and you get your answers. Are you getting my point, beta? Got it? It is quite simple that way. Yes or no? So that is how you apply what you have learned into questions when they come. Now, again, here is the question. Remember, the question may look very complicated. It might be the simplest one that you will see in a while. A particle of mass m and charge q is thrown from origin at time t is equal to 0 with a velocity 2I plus 3j plus 4k. This is my favorite velocity. In a region with uniform magnetic field 2I along the x-axis, after time t is equal to 2 pi m by pi m by qb, an electric field is switched on such that the particle moves on a straight line with constant speed. What is the value of E? And I wait for your answers. So, how do you go about it? See, I told you, whatever cases can come in a JEE, we have already covered it. And now see, you see how you apply those cases. Now remember, there is something very special about the time that is given here. This time is time period divided by 2. Remember, time period does not depend on the value of V or in which direction it is projected, right? So this is after half a circle. Yes or no? You understand this? We also understand that magnetic field is along the x-axis, so x wala velocity will not change. Only the velocity along y and z will change because this particle will be rotating or moving in circles, helical path obviously, and this circle of this helical path will be in the yz plane. Yes or no? Please raise your hands and let me know. So, and now the time is given in such a way that it is half of the time period. So, if initially it was 3j plus 4k, now it will become minus 3j minus 4k, but 2I will remain same. Yes or no? No or yes? Now that is the first thing that you have to understand. So if you understood this, if you could find out the velocity after this time, that is first part of the question done. But after that, remember the case which we had done in which we had perpendicular velocity and electric field and magnetic field, and I told you that there could be a case where electric field and magnetic field, they both cancel out each other, the forces cancel out each other and the particle will move in a straight line. That is also known as the Hall effect. Did I tell you about this Hall effect? Yes or no? Magnetic force and electric force will cancel each other out. Yes or no? And the particle moves undeviated along a straight line. Yes or no? That means the magnetic force and the electric force has to cancel out. So QV cross B plus Q into E must cancel each other out. So E vector becomes minus of V cross B. So now the value of V. You now know the value of B. You take the negative cross product of this, and that will land you with the answer. Do we understand this, bacha? Was it such a difficult question? No. What we have applied here is the knowledge of the time period, helical path, and then E and B cancelling out. The forces due to E and B cancelling out each other. So will you remember this, bacha? That takes us to the last question of this class today, and it's a simple one. Again, it's a multiple choice question, so you must be careful because most tough questions are definitely multiple choice. A particle of specific charge ratio q by m is projected from the origin along the Positive x-axis with a velocity 10 to the power 5 meter per second in a uniform magnetic field B is -2 into 10 to the power -3 k times Tesla. Choose the correct alternatives and I'll give you 2 minutes to do this. The most difficult question. Multiple choice. Okay, it is pretty straightforward. The particle is projected like this from the origin along x-axis. So the center of the circle should lie on the y-axis. Yes or no? So option number 1 is correct. Time period is 2 pi m by qb. You find the value of time period. It is coming as 10 to the power -7. So option B is also correct. Radius of the path is mv by qb. It is coming as 5 by pi. Option number C is also correct. Now time after time 1 by 4 into 10 to the power -7, which is t by 4. At time t is equal to 0, it is here. At t by 4, it will be here. At t by 2, it will be here. At 3t by 4 will be here. Velocity only changes in direction, does not change in magnitude. So after t by 4, it will be along positive y-axis and the velocity magnitude will remain same, 10 to the power 5 j meter per second. So option number D is also correct. Did you get the answers, Peter? Do you understand how it is done? Okay, then that was the last question for this class. And we have covered a variety of questions in today's class on magnetic field and a magnetic force, magnetic field. Not so much, but we have done magnetic force on a current carrying wire as well as on a charged particle, and we have dealt with questions on electric field and magnetic field. I'll wind off this class today and I'll see you tomorrow. If you have any doubts, please ask. Bye bye.